Welcome here, everyone, to From Pixels to Insights, getting started with imagery in FME. Today, I am joined by our lovely panel of 3 presenters, and I'll pass it over to Donald to introduce himself.
Hi guys, I'm Donald. I'm originally from Ireland, but have moved to Vancouver about 6 years ago. I'm with Safe Software about a year on the technical support specialist side with FME Forum.
And my name's Ali. I'm also on the technical support specialist, same team as Donald and Kaylin. We answer your questions on the community. We take your support tickets, and you can see us doing webinars like this.
And hello, I'm Kaylin. I am also a technical support specialist on the FME Forum side.
Awesome. And I'll just note as well, this is Donald's first webinar with us, so very exciting. Super happy to have him join us and for all his time in preparing content, especially to all of our presenters as well, of course. And I want to shout out Dimitri on the back end. He was a great support in content development for this webinar. It's great to have his expertise, and he's also joining us here today on the back end. So for any questions that you might have, please do get those into the questions panel as we go along here. You'll see it on the bottom right there. And that way we're able to reply directly to your questions, and we'll also have live Q&A at the end as well. Keep letting us know where you're tuning in from in the chat on the bottom right. We do have a poll coming up very soon, so keep an eye on that polls tab. You can also share your emoji reactions with us during the webinar. So use that react button and let us know how you're feeling throughout. And then we also have the help button on the bottom left. So if you have any audio or video issues, you can click that for 4 simple steps to take. You can also download the slides by clicking that button on the top right of the PDF. Okay, with that, I will introduce here our peak of data integration. So this May 6th to 8th, 2025, coming up quick here, join us in Seattle, Washington. We do have early bird pricing available until February 7th as well. So take advantage of that if you have yet to do so. And we hope to see you all there. And we have our poll here. Let me go ahead and launch that in the polls tab. So you can all head over there now and you should see it. We'll give everyone a moment to vote. We'd love to know, how often do you work with imagery data? Is it daily, weekly, monthly? Maybe it is not as often yet, or maybe you have yet to do so. I believe the content here today should definitely bring value no matter what camp you fall in.
Lots of weekly and daily users. That's surprising. Awesome.
Yeah, it's interesting to see it's pretty split between, like, it's almost like a quarter of the top 4.
And for those of you that have never used imagery in FME yet, you're definitely in the right place. So welcome.
Amazing. Looks like all the votes, or most of the votes, are in now. So thanks everyone for voting. We appreciate that insight. Okay, with that, I will prompt our presenters to turn off their webcams just so we can save on some bandwidth for the remainder here. And I will pass things over to Donald for our agenda.
Yeah, thanks, Elizabeth. So good morning all, and thank you for joining. To kick us off, I'm going to give us a quick run through of our agenda. So the introduction and imagery fundamentals, I'm going to be taking care of this part. And then I'll hand it off to new imagery resources, which Ali will go through. There's some great new transformers that we've created that we want to show off. Then we're going to hand it off to Kaylin for common imagery tasks in FME. And then we're going to hand it back over to me, who will finish off with advanced imagery. And finally, Ali will wrap it up with the conclusion. We have a next steps and resources section, and then we'll finally end with a Q&A, which we hope you all ask some questions. So without further ado, I'm going to kick us off with an introduction. So good morning all, and welcome to our webinar, Pixels to Insight, getting started with imagery in FME. My name is Donald Mateer, and I'll kick us off. To those that are new to FME, or this is your first exposure to FME, FME is the only all data any AI integration platform. Today, we are going to dive into just one of these data types, imagery. We're going to discover how FME can transform your imagery into notable outcomes, streamlining your workflows, integrating data where it's needed. But what do we mean when we talk about imagery? Firstly, we need to distinguish between imagery, photos, and rasters. So a raster is the technical accurate term for referring to a data structure that organizes information in a grid of pixels. Imagery is a type of raster typically captured by sensors on satellites, planes, drones, or other platforms. Photos, I'm sure we're all familiar with photos. It's a more generic term, commonly used to describe images captured by cameras. Now, there's a huge array of data and models to work with. One of them is a DEM, or a digital elevation model, a specific type of raster where the grid cells store elevation values commonly used in geographic and topographic applications. FME works effortlessly with raster data. There are over 50 transformers dedicated entirely to raster processing, and they all start with the word raster. That means whether you're analyzing satellite imagery, transforming digital elevation models, aligning rasters, or extracting key information, there's a tool specifically designed to make your task faster and easier. But what are the benefits of imagery? Imagery processing unlocks the potential of visual data, transforming raw images into actionable insights for smarter decision making. For example, satellite imagery can be used for water management and urban development, while AI-driven tools can identify features like vegetation or infrastructure from drone images, enabling environmental monitoring or asset management. With imagery processing, the possibilities to streamline operations and uncover valuable insights are endless. But of course, there's going to be some common frustrations people face with imagery data, and these include the difficulty managing large volumes of imagery data efficiently. So for example, handling vast amounts of raster data, especially from satellite or aerial sources, can be daunting due to file size, formats, and the need for structured organization. There's complex processes. So preparing images to extract actionable information from raw imagery often requires multiple complex steps involving data transformation, analysis, and integration. And of course, there's limited resources for accurate image enhancement and analysis. So organizations may lack the tools or expertise needed to enhance imagery and drive meaningful data. But of course, there is a better way with FME. You shouldn't have to experience those problems. By leveraging FME's capabilities, organizations can manage and process large volumes of imagery efficiently, enhance and analyze imagery accurately, even with limited technical resources, and simplify complex workflows to extract actionable insights from raw raster data. I'll now move on to the imagery fundamentals. And in this, we're going to talk more about imagery terminology, how imagery is used, the different formats used in imagery, and finally, how imagery is represented in FME. So raster terminology. Here I'll cover some common terms used in the imagery world. So imagery. This is any type of photograph captured by electronic devices such as satellites, aircraft, cameras, and mobile phones. Imagery is comprised of pixels. Within FME, these are referred to as cells. This is the smallest unit of a raster image representing one or multiple values. The total number of cells will define an image resolution. The resolution is the real world size of a pixel. High resolution has more pixels, so it will be more detailed, while low resolution has fewer pixels. It will be less detailed. Some other important terms in the world of rasters include raster bands. So a raster dataset can contain a number of different layers known as bands. Another way of looking at this is to say each cell can consist of a number of values. And then we have a palette. A palette represents each of the pixels in a raster and lists each of the colors associated with each pixel. Types of rasters. There's two main types of rasters, numeric rasters and color rasters. Numeric rasters are typically represented as single band with continuous or discrete numeric values. These numbers can either represent smooth changes, like elevation or temperature, or categories, like land types. For example, 1 equals forest and 2 equals water. These rasters are typically used for analysis, modeling, and visualization in GIS and remote sensing. So, for example, a digital elevation model would be a numeric raster. Color rasters. These rasters represent multiple bands combined for visual interpretation. RGB rasters combine 3 color layers, red, green, and blue, to create images we can see and interpret. These rasters are widely used for visualization, photogrammetry, and mapping. Examples of these would be aerial photography and satellite imagery. How is rasters used in the industry? Raster data is commonly used for understanding, engaging, and communicating information across platforms and communities. Here are some common uses. So in digital photography, it captures moments, landscapes, and events in digital form, often used for artistic, personal, or professional documentation. With web design, it enhances visual appeal, user experience, and communication on websites. Attachments. So these are support communication by including visual information in emails, reports, or documents. Orthophotos, they provide geographically accurate images for mapping, planning, and analysis. And then historical archives. It preserves visual records of cultural, historical, and environmental significance. When working with rasters, there are many different formats that can be used. Here are some of the common types that people work with. A JPEG, this is often used in digital photography and casual image sharing. PNG, this is often used for web design for icons, logos, and graphics requiring transparency. And a GeoTIFF, often used in satellite imagery and digital elevation models. But FME can connect to much more. Just look at this image here. FME is capable of working with each one of these formats. Within FME, some common terms may be referred to slightly differently. A pixel is represented as a cell in FME. A channel would be represented as a band. A raster or image would be represented by a feature type, and resizing is known as resampling. As mentioned, an image is represented as a reader or writer feature type. Within FME, a reader is how our data is read into our workspace, and a writer is how we choose that data to be written out and represented. I'd like to now hand over the next part of our webinar to Ali, who will lead you through the new resources and transformers section. Thank you.
Yeah, thanks, Donald. So that was a great overview of an introduction to imagery fundamentals, benefits of imagery, and how we interpret it in FME and what we support. So now we're going to jump into new resources and transformers. So before getting into this, we're going to do a chat storm at the end. So a chat storm is basically we'll ask you a question, we'll give you the duration of this section to think about it, and towards the end, we'll give you another minute and a half if you didn't have time to think about it. And then from the count of 5, we'll tell you to press, or we'll say go, which is enter, and then your answer and the amount of answers that people within this room are entering there is like, that's the definition of a chat storm. So the question we would like to have you keep in mind is what other imagery tools you would like to see in FME. So getting into this section, we've created new resources in Hub Transformers. So the new resources that we've released on the knowledge base is common imagery tasks. That's going to be shown a bit later on in this webinar. Also, there's an article dedicated towards it. Definitely check it out. Links will be provided in the chat for this. And then imagery basics, also a great introduction to imagery, and then it goes into a bit more advanced details. So if you're interested, definitely check that out. And then image compression as well, which is a really good read and also has some practical examples there. Oh, thanks, Elizabeth. Sorry. And then, yeah, this is for context, so apologies. And then towards the bottom there, those 4 bullet points at the end, we're going to go through image watermarker, image identifier, image color adjuster, and then image haloers, which we'll get into detail in the coming sections. So for the image watermarker, how this works is you bring in an image that you would like to be your watermark. It can be a logo, it can be an icon, or pretty much anything of your choice. And then bringing in a base image as well, which it can be a photograph, scanned map, PDF, and then your watermark will be overlaid on top of that base image, which this transformer does and what we've built for you here. So if you look on the right there, this is its parameters. You can adjust the angle of your watermark, choose its opaqueness, and then the column and frequency you'd like that watermark to be within that base on that base image when it's overlaid, and then the scale factor that you'd like to set it. So jumping into the demo here. So we have a geotiff of Cole Harbour in Vancouver, and then a PNG raster of, or a PNG image of our FME logo there. So we'll run our workspace, and then once that's run, you will see that FME logo was overlaid on top of our geotiff there, which is pretty cool. All good. So the next one is image identifier. So this is another great transformer. It's designed for use with Llama. So we used a Llama here, and it uses the Lava multimodal model. And quickly, Lava is basically an end-to-end trained large multimodal model that is designed to understand and generate content based on both visual inputs and textual instructions. Here we opted for textual instructions, as you can see on the right there. We have our Llama URL, which is the default. And of course, I'll say this during the middle of this. All information you can check out on the hub for more details about our transformers. And then our prompt, which is our textual instruction there. And this will be set in our next demo here, which is what does this image contain? And then intended for use with JPEG and PNG image formats, which is a limitation to this transform or the Llama here. So getting into the demo. So here we have a image that we've grabbed from Unsplash, which is architecture here, an RGB image. And what we're going to do is run our workspace with the same parameters that you've seen in the previous slide, which is what does this image contain? So once this runs, it will output an attribute that's content, as you'll see in a moment here. And it gives it a paragraph description of what this image contains. So we'll open that here. And you can see there, this image shown a modern abstraction art piece with, yeah, so it gives an explanation of what that image contains, which is really cool. All right, so for our third transformer that we've developed is the image color adjuster. So the image color adjuster, it sits in adjusting your image's color. We have 5 options here. We have brighten, color correction, grayscale. You can invert your color and gamma correction. And also I wanted to give the gamma correction here in this transformer is inspired by one of our colleagues, Dave, which he made the RGB gamma corrector. So shout out to him. And then also this is intended for use with JPEG and PNG image formats. So as you can see on the right there, that's its parameters. And you have those 5 options and 5 output ports. So jumping into the demo. So we have the same image from our other transformer demo, which is the image identifier, that same architecture there. And what we're going to do here is we're going to select this time grayscale. So we'll click OK, we'll run this workspace, and then with the magic of this transformer, it will be grayscale, which is really awesome. All right, so last but not least is the imagery haloer. So what this transformer does, it creates a halo around an image, and it's basically a gradual blend of the surrounding user selected color. So as you can see on the right there, you can select a halo color. We've chosen a blue here, but you have all those color options to choose from. And then the number of buffers and buffer size used as ground units. And then keep in mind your image that you're bringing in needs to be georeferenced for this transformer to work. And then as a result, it creates smooth effects and transitions from imagery to a background. So you can use this in your presentations, websites, or whatever you need there. And it's usually used for focusing on a particular area, so an area of interest, for example. So jumping into the demo. All right, so we have a GeoTIFF, which is georeferenced. This is a image from a neighborhood from Austin, Texas. So we can zoom in here and you'll see details of that image. And then what we're going to do is bring in a polygon here, which is basically a clipped area of our GeoTIFF image over there. We've prepared that ahead of time, and we've clipped a particular area of that GeoTIFF. So we're going to open our transformer here. We're going to select our color. Let's choose lime green, and we'll leave the buffer size and the other one as default, and then we'll run this. We'll set our parameters, and you will see here it selected a particular area that we want to focus on, and then the rest is that lime green color, which is really awesome. So you can see there it's only focusing on that part of that neighborhood. All right, so I hope you guys had a chance to think about the question that we asked towards the beginning of this section. We'll give you another minute, and then we'll count by 5 and see what you guys want to see with what other imagery tools you'd like to see in FME. So we'll give you guys, another 30 seconds here. I hope you guys are enjoying this webinar so far. Thanks for coming. Hopefully great weather for where you are, wherever you are around the world.
Yeah, and I think we're going to attempt to do it where we say like 3, 2, 1, and everyone presses enter at once, right? Is that right, Ellie?
That's right, exactly.
Okay, so hold on to our answers.
Yeah, exactly. All right, so we'll count from 5. So 5, 4, 3, 2, 1, go.
Awesome.
That worked really well. Cool. So now we can skim through all these responses. Amazing. We got a ton.
Mm-hmm. Yeah, fantastic ideas, guys.
Any in particular we want to shout out here, team, that you saw?
Seeing a lot of change detection between two sets of images. I wonder if that's like for captioning maybe seasonal changes between place or...
I've noticed that too, yeah.
Lots of object detection as well.
Yeah.
Zonal statistics.
Mm-hmm. Classification. SAR. SAR is a really cool one. Yeah, awesome. Thanks, guys. If you still haven't entered your response there, you still can. But we're going to move on to the next section here, which I will pass on to Kaylin for common imagery tasks in FME. So take it away, Kaylin.
Thanks, Ellie. So we just reviewed some super cool new imagery tools, but now we're going to show you a couple demos on how you might build out your own custom imagery solutions. So in this section, we're going to get familiar with a scenario, and then we're going to start to build that scenario out. So let's get familiar with our scenario. So your organization's marketing team is preparing for an upcoming user conference. They've requested help from your department preparing photos for an online web portal they're curating. This is where attendees will go to access their agenda, join sessions, and find information about the event. Marketing has provided this project with 4 criteria, so let's go through those. So web images need to be watermarked with the company logo. You can see we're staying on theme here. Watermarks need to be black and white as well as transparent, and web images need to be a minimum width of 800 pixels. And although it's not listed here, we really should be delivering the images back to the marketing team in a web-friendly format. So we have about 1 demo per marketing criteria we're going to meet. And we can get started by getting familiar with our data. So this is what we're working with on the left, and this is the output we're working towards on the right. So before doing anything else, we need to prepare the logo for overlaying. So first we need to convert the logo to black and white, and sometimes this is called grayscale. We're going to use the raster expression evaluator in one raster mode where A represents our raster and the following digit corresponds to a band. So in this case, when you say A and then bracket 0, that's actually regarding our red band. In our band expression or formula, we need to multiply each color channel or band by a weighted sum. The weighted sum will control grayscale intensity, and we're going to see how this works in the following demonstration. Now we'll jump into the demo video.
Let's start building the scenario. This scenario will be conducted in 2 steps. Firstly, we'll prepare the watermark, and then we will combine the watermark with the images provided from marketing. To begin our analysis, let's go ahead and bring in our source data set. Our logo is in the PNG format. I'm going to make sure I'm in something called feature caching mode, and I'm going to do a partial run. The log file will tell me our file is read successfully, and now we can see our logo in the graphics window. By clicking around on our image, we can quickly confirm how many bands are in this image. So we have a red, green, blue, and alpha band. Now that our data is in FME, let's start meeting marketing requirements. The first thing we're going to want to do is convert to black and white. We can type and add a raster expression evaluator using our quick add menu. The raster expression evaluator will manipulate raster images. In this case, we're going to want to use it to course to gray 8. And then we're going to want to supply an expression. This expression should be used to convert our image to black and white or grayscale. To convert an image to grayscale, we need to multiply each color channel by their weighted sum, and this will control grayscale intensity. By changing these values, you will change the grayscale intensity that you see in the output image. So by using more average values, you're going to see a more muted output with very little contrast. Whereas if we're doing something like this, we'll see a little bit more drastic results. Our logo is fairly simple, so I don't expect results to change too much depending on the formula you use. Then lastly, before moving on, we're going to want to preserve our alpha band or our 4th band. We're going to click OK, and we can do another partial run to see how our image has changed. You'll notice that now the image is in black and white, and we actually only have 2 bands. So we have our grayscale band here, and then we also have our alpha band, which we preserved. We will need to use our alpha band in the next step.
Awesome. So now that the image is in grayscale, we can apply transparency. But to understand transparency, we have to be familiar with the concept of an alpha band. So what is an alpha band? An image is usually made up of colors like red, green, and blue, and sometimes there's an extra layer called the alpha band. And this alpha band is what controls transparency. Each pixel in the alpha band will either have a range value of 0, meaning fully transparent or invisible, or 255, meaning fully opaque, which means completely visible. Any value in between 0 and 255 will carry some form of semi-transparency. It is worth noting a lot of raster transformers will also offer parameters to control transparency, so this is not the only way to do this. Let's take a look at how it's done.
Now that our logo is in grayscale, we need to apply some form of transparency. We can notice that our alpha band right now is 255. This means that our logo is not transparent whatsoever. We will need to use an FME tool to reduce that alpha band value to apply transparency. Though there are multiple tools that can be used to do this, we're going to use another raster expression evaluator. Type on the FME canvas to add your raster expression evaluator. Connect it to your data flow, and open parameters. The first thing we're going to want to do is preserve our gray 8 band. So we're going to preserve our first band, and then we're also going to want to preserve our alpha band. However, we're going to want to subtract about 100 from it. This will reduce the alpha value from 255 to 155, applying about half full transparency. If we click Run, we can take a look at how transparent our logos become. We can see the colors are more muted, And we can now see that our alpha band has a value of 155, meaning it is partially transparent. Now that our image has been prepared, we can write it out so it can be used in step 2. I'm going to use a feature writer to write out our data. I will explain why during part 2. So we can go ahead and add our feature writer. We'll connect our data. We'll confirm we have the output paths set. And we will click OK. Lastly, we can run our data to export our file. We can see we've got a successful translation and our data set has been written.
So just going to note that we actually could have done that black and white and transparency step in a single transformer. So we could have actually put both equations or formulas in a single raster expression evaluator. Okay, moving on. So now we need to combine the image and the logo. So now that our logo is fully prepared, we need to overlay it on the background or web images. So first we need to create placeholders for logo locations, meaning we need to create a point in each location where we want the logo overlaid. There are lots of ways that this can be done. We're going to demonstrate the 2D grid accumulator, but you could have also used a combination of the tiler and center point replacer. Once we've created our insertion points, we're going to use a Mapnik rasterizer to replace each point with a logo. The Mapnik rasterizer gives you fine control over symbolization and labeling using the Mapnik toolkit, so it's really an asset here. Alternatively, from using Mapnik, you could have cloned the image, extracted the point coordinates, and then offset each logo to their respective XY. So let's take a look at how this is done in FME.
Step 1 is now complete. We have prepared the watermark to be overlaid. Now we can begin on step 2. In step 2, we will overlay the prepared watermark with our other images. So we can start by taking a look at what marketing's provided us. They've shared 2 JPEG files that they would like watermarked. We can drag and drop our data onto our canvas and leave all parameters as default. We will be reading as a single merge feature type. We click OK to add our reader feature type to the canvas. We can move it to the correct location. And before caching my reader, I'm actually going to begin to build out the rest of the translation. Our first task will be create grid insertion points. This means we need to create a point at each location where we would like the logo overlaid. We can use a grid 2D accumulator to do this. This transformer will create a regular grid of points or rectangular polygons that will span the extent of all input features. Let's add our 2D grid accumulator. We'll connect it to our JPEG. Double-click to set the parameters. Because we're working with 2 images, we need to enable group by processing, and we need to group by FME base name. This will ensure that the same processes is happening on each image, each image is being handled as a separate feature. We're going to change the grid type to number of cells, and we're going to want to ensure that the grid to create is points centers. We want a total of 9 logos overlaid on our images, so we are going to create a 3x3 grid matrix of points. We're going to click OK. Now we can do the overlay. We'll use a Mapnik rasterizer to do the overlay. We will connect the output port from the 2D grid accumulator as well as the original contents, image contents. We can double click to set parameters. We'll need to enable group processing again on FME base name so that this is carried out on both images, and then we can set raster properties. We'll change the resolution to cell spacing and give cell spacing a value of 1. Now properties have been set, we can go ahead and edit our rendering rules. Here's how we control the styling to be done on features. So right now, we need to actually move our rasters up so that they come first, and our grid or image, which I'll show in a second, is actually overlaid on top of the original JPEG. We'll change our symbology to raster and our grid to point. Now we need to edit our point style. Mapnik Rasterizer will allow you to change the symbol type to image. We'll set the image file to our newly created watermark. So you'll notice that we did use a feature writer in part 1, and this parameter does allow you to set an attribute value, meaning that you could actually use a more dynamic approach to this and have FME datasets specified in here, so everything would be handled dynamically. But just to save on transformer count, we're going to hard code this today. The last thing we want to do is, because we don't typically see watermarks perpendicularly, is we're going to want to add a rotation so that our watermark is rotated 45 degrees counterclockwise. We're going to click OK and OK again, and let's take a look at what this produces. So you'll notice that we received 2 output photos with a watermark that is rotated properly and transparent.
Awesome. So the last step to satisfy is size requirements. We're going to use the raster resampler resize images. We're going to resample to 800 columns, and it's going to reduce the size of this image by about 9 times. We're going to use existing raster properties to proportionally scale or resize along the y-axis or calculate the number of rows. Let's take a look at how the raster resampler changes image size.
Now that the watermark is overlaid, we need to prepare the images in the correct size. To do this, we need to change the resolution to have only 800 columns. We can do this by using a raster resampler. To change an image size in FME, you need to touch or change the resolution. Because we only have 800 columns specified for our resolution, we need to proportionally create the number of rows. And we can do this by using existing raster properties. We're going to type and add a raster property extractor. This is going to extract properties like how many bands, how many columns, and how many rows are in the raster. There are no parameters to set for this transformer, so we can go ahead and run it. Now we can resample or resize. We're going to add a resampler. We're going to connect it to the output port of our raster property extractor. And we're going to specify the number of rows to be 800. Now we've satisfied marketing requirements, but we also need to calculate the correct number of rows. To do this, we'll use an equation. Let's open the arithmetic editor. I'm going to paste in an expression that will proportionally create the correct number of rows and then round that number to a whole number. And that's because we can't have a decimal number of rows in our output raster. We're going to click OK and OK again, and now we're ready to write. We're going to write to Google WebP because it transmits well over the internet. Let's go ahead and add our writer. We're going to search Google WebP, and we'll select our output dataset. We'll store them in the same folder as our marketing images, and we'll leave the raster file definition as automatic. The only thing we're going to want to do is add a suffix saying watermarked. That way we know this image has the watermark overlaid on it. We're going to click OK, connect our data, and then we can run our workspace to write or export the photos. Let's take a look at our output. We can see we have 2 new WebP photos.
All right, so I actually didn't prove the resolution at the end of the video there. However, if you were to run this workspace, navigate through the feature information window down to raster properties and find the resolution parameter, you would see about 533 rows produced for those 800 columns. So taking a look at the scenario in a whole, we've successfully delivered the images back to our marketing team in the Google WebP format. So why Google WebP? Google WebP has a great reputation for supporting high compression while maintaining high image quality. Not to mention it's compatible with most modern web standards, meaning it's really easy for people to work with if they're using various browsers. So our scenario has concluded, but instead of having your marketing team approach you every event season, you could consider using the FME platform to create a self-serve flow app or automation where the marketing team can upload and watermark their own images using an online self-serve tool. Awesome. And now Donald's going to run us through advanced imagery.
Yeah, thanks, Kaylin. That scenario really highlights the real-world applications of working with imagery data within FME. So great job. So our last section is advanced imagery. So I'm going to briefly show everyone the amazing capabilities of working with imagery in FME and the endless possibilities. I'd like to quickly give a shout out to Dimitri for the amazing support and providing many of the outputs for this section. So our first slide shows this amazing imagery tool. This is a farmland monitoring tool which calculates NDVI, which is the normalized difference vegetation index. With this tool, we're able to compare two images in their own format. So for example, RGB, IR, which is infrared, and NDVI. I'll just give a quick explanation of infrared and NDVI. So infrared is a type of light that is invisible to the human eye, but can be detected by specialized sensors. It's often used in farming for detecting crop health and forestry for detecting areas of deforestation. NDVI, it is a simple way to measure the health and density of vegetation using satellite or aerial imagery. This is a great tool that can highlight just how healthy a farmer's crops may be when selecting the NDVI option, or it's a great way to detect deforestation when selecting the infrared option. This tool will be shared for everyone watching, so be sure to play around with it and use it for yourself. Draping is also a very useful tool. So this means placing a flat 2D image, like a map, aerial photo, or satellite image, over a 3D surface, for example, a terrain model. As you can see from our slide, the city of Vancouver is represented while also having a 3D visualization of the local mountain ranges. This can be incredibly useful when dealing with terrain models and city models. For really advanced uses, it can even be used in virtual tours for tourism. Reclassify numeric rasters. So imagery classification using numeric rasters means updating or changing the values in a grid-like image made of numbers to group or simplify the information. So imagine a map where each square or pixel has a number representing something like land type. 1 equals forest and 2 equals water. Reclassification changes these numbers, like grouping all water types into one number, making it easier to analyze and understand the data. Examples of this can include land cover data and slope data. Lastly, but certainly not least, is how FME can integrate with other platforms and implement deep learning models. These are computer models that are designed to learn patterns and features from images. These models use a type of artificial intelligence. For example, it can look at pictures and learn to recognize objects like cats or cars by analyzing features like edges, shapes, and colors. As you see in our slide, using Pictera, we are able to identify points of interest. In this case, we wanted to identify sea lions on a beach. It could also be used to identify cracks on roads or pavements, as seen in our second picture. The possibilities are almost endless with deep learning models. Using the recognition connector, this allows us to access the Amazon Rekognition Service AI computer vision service. In the examples on the slides, we're able to detect emotions. As you can see from my face, it was able to detect happy emotions, surprise emotions, sad emotions, and angry emotions. Construction or medical companies can implement this technology too using a PPE check. This helps check to see if people are wearing their personal protective equipment. The possibilities are really endless. They were just some examples of advanced imagery and what is truly capable within this world. For our next webinar, which is coming next year, here's a little sneak peek of what to expect. We'll be discussing bands and palettes management in greater detail. We'll be understanding raster interpretation. We're going to be showcasing some amazing examples of draping, reclassification, deep learning, and much more. And we'd also love to hear from everyone here. What would you like to see? So this wraps up the advanced imagery section. I'll hand it back to Ali, who will wrap it up with the conclusion.
Thanks, Donald. Yeah, that was a really great overview of the advanced imagery that Dimitri has done with some of them. And then also, yeah, our webinar coming next year, which is super exciting. My favorite from that part was calculate NDVI and compare imagery, and the recognition one. Love that, Donald. So just to summarize this is as we've explained to you and showed some demos to you, you can turn your imagery into notable outcomes for your FME workflows. And we've showcased different use cases, resources, and custom transformers that you can check out and try for yourself and build your own workflows from them. And then, yeah, the advanced use cases that Donald put perfectly. And of course, more coming soon with that webinar and other content, so stay tuned. And yeah, we've been doing this for over 30 plus years of solving data challenges, over 37,000 members on the community, over 25,000 organizations, and 140 global partners that we have in 128 countries. So thank you all, and we've been pretty established with what we support here. And yeah, we've started focused on GIS towards the beginning here with less than 10 formats back in 1995. But over the years, we listened to our customers' needs and what they basically needed. And now we support more than 500 different formats. And you can see just some of them there, which is really amazing. And I will pass it over to Elizabeth for other resources.
Amazing. Thank you, Ali. Okay, so just to wrap us up here, we're all about free resources here at SAFE. You can get free instructor-led training over at our academy. And I'll also highlight our webinars. We've got lots of upcoming ones, one more this December, and then some more that are already posted for the new year. So check those out. Our podcast program, if you're looking for some more audio-based learning, we also have a handful available over at EM360. And in terms of next steps, we'd love to help you get started with anything that you may be needing a hand with when it comes to your data challenges. So I'll go ahead and promote a link for that too. If you'd like to email us direct, you can just click that handy button there. And our FME Accelerator course, it is 90 minutes free of charge, and it's quite helpful as a basis for getting started with FME. Claim your community badge. So if you're a member of our FME community, we have a badge code for you to redeem today. I will drop that in the chat here. And if you aren't yet a member, please do check it out. It's a great place. You can network with other users and experts alike and gain solutions to your challenges there. Once again, shout out to the Peak of Data. So that is happening this May 6th to 8th. Be sure to register for early bird savings. Okay, and with that, I'll invite our presenters to turn back on their webcams, and I'll invite Dimitri to the stage as well if he'd like to join us, and we can take a look through the questions together. We did get some great questions that came in throughout here. It does look like Dimitri got to most of them, which is awesome, but maybe there is one or two we want to elaborate on, or might be a couple we haven't gotten to yet as well.
While Dimitri's joining us here, there's a question about converting GeoTIFF to cloud-optimized GeoTIFF. Absolutely, FME can help with this. We have readers and writers for both of those formats. Another one here about reading cogs from S3. That is definitely doable. We have an S3 connector transformer, which will allow you to read, upload, and write to S3 buckets.
Hello, everybody. Yeah, so I tried to answer as many questions as I possibly could. Sorry if I didn't answer some. Maybe I also checked the chat window and saw some questions there. So maybe I just go in general over some popular requests. So maybe what we have to understand that FME is not a data extraction tool per se. So it can extract certain things under certain conditions. We have some transformers allowing that. For example, raster convolver, which, for example, allows you to do change edge detection and many other functions. We have raster expression evaluator, a great transformer to change pixel values based on different criteria. And after that, you can use things like raster to polygon coarser to extract polygons, or maybe extract points with raster cell coarser. For example, I was able, using NDVI or NDWI, to extract vegetation polygons or water polygons. Then the watermarking example, someone asked whether it makes sense to create watermarks. Probably on Imagery, no, but we showed you in Kaylin's example that you can overlay different things on rasters. For example, you can have a vector layer of your roads, center lines, or zones, and you can put them on top of your raster and create a raster output with combining information from two or multiple sources. So someone also said that certain operations are very quick to do in Photoshop or GIMP, but FME is not about dealing with one image. Imagine 10,000 images, then Photoshop won't help you, right? So, well, it might, but it may take years. So you would define a transformation and then pass 10,000 images, and you don't care how much time it takes because it runs on the background. And on the other hand, you can publish that service as just a simple web browser form, and people will just drop their image and get back the results, and they don't have to know how FME works, how Photoshop works, how GIMP works. It just works for them. Then I saw people asking for LiDAR processing, so it's a point cloud operation. We have lots of point cloud transformers. They, to some extent, are similar to rasters, but of course they're different. And we have, again, lots of webinars about LiDAR, and maybe also we need to create a 101 for LiDAR webinar as well. Then people are also asking about particular operations, whether there is a transformer for that. Often we cannot create transformer for every task, but often it's just a chain of transformers. You would use one transformer after another, and, for example, do blending. So, for example, you saw a halo transformer. You can similarly take two images and blend them together using a very similar technique. So, but behind that halo transformer, if you open it, you will see that there is a chain of transformers performing this operation. So, and there were lots of questions about AI and feature extraction. So we have some connectors, for example, this, which is a geospatial data feature extraction platform. I built a custom transformer that connects to it, and it works really well. So you would train it on the Pictera side and then run inside FME and automate, for example, the image delivery. So, or you can clip, for example, your imagery so that you spend less credits on Pictera side, and so on. Or you can upload detection areas in GeoJSON, but you would take them from any vector format that you have them in. I also playing right this week with the RoboFlow, and I get really great results with detecting things on images. So you probably will hear more about that later. And we had lots of AI webinars this year. So maybe Elizabeth can share some links, and they talk about how to use Llama and how process images, including, well, among other things.
Yeah, and Dimitri, I also just published a poll while you were chatting, just asking folks if they'd be interested in a LiDAR 101 webinar. Be good to gauge. So go to the polls tab if you don't mind placing a vote. We'd like to see the interest in that. Yeah, and I'll drop some of our latest AI webinars in the chat as well. We'll have one coming you heard it here first, folks. We'll have one coming in the new year. So stay tuned for that as well. Featuring special guest speakers yet to be announced. Okay, any other questions we might want to pick out here, team?
I think Dimitri killed it with that one-stop answer.
Awesome. Perfect. Okay, well, while our team is just taking a final look through here in case there is any that we haven't gotten to yet or covered, I'll just give a huge shout out to our presenting team. Thank you so much for all your time preparing this content for us today. And Dimitri and Dawn for your help with content advisement and support there as well. And to our whole audience, thank you so much for joining us today. We hope you gained a lot of value from the content. If you do have a moment to fill out our webinar survey, we really appreciate any feedback. It really helps us to keep improving our program. I'll drop that in the chat there too.
Just a quick note, if you didn't have time or you have more feedback, we do have this product update post, so always feel free to drop your thoughts there if you have any extra ones after the webinar.
Perfect. Okay, and just final call out to the team. Was there any other questions we wanted to get to here before we conclude?
I think we'll be able to provide some resources probably for a lot of these questions. You'll receive an email after.
Okay, awesome. Okay, thank you so much, everyone. Again, hope you all have a great rest of your day. And yeah, we'll see you next time. Bye for now.
Thanks all.